Swayam Prabha. Digital India. Educated India.
Hello everybody. So today we will start lecture 3 of module 6. We have already covered, after the introduction we have covered cast iron and wrought iron, and we told that we will carry on with ferrous metals, particularly steel, which we are presently using in our building industry quite extensively. The items that will be covered in this particular lecture is manufacturing of steel, then briefly on the properties of steel, and then rolling of steel and joining of metals, that is particularly steel. So, we understood in our previous lecture that you need pig iron, which was extracted first in the blast furnace, and then it was used for either making cast iron or wrought iron, and there also I told it is used, or the initial item for steel making is again pig iron. So, the same pig iron comes here and helps in the manufacturing of steel. So, the first industrial production started in 1856, and since then we find the replacement of cast iron and wrought iron by this particular item, which is steel, and steel is now extensively used, replacing cast and wrought iron into building industries, into bridges, highways, roadways, etc. So, the principle remains the same. Here again, if you see the picture, this is a Bessemer converter, which was the first in use for large scale production, is having the same concept of pushing in hot air. As you can see, the hot air is bubbling out into the charge. What is the charge? Here again it is the limestone and the pig iron, and this, on the upper part, the slag actually comes up and the steel is tapped. So, here again it is air, hot air entering, heating the entire charge, the slag is coming out and the metal is being extracted. Various other processes are also practiced to get steel, and the steel ingots are now obtained and they are now taken for further processing. Now, steel are again of 3 types: low carbon steel, medium carbon steel and high carbon steel. Low carbon, as I have already mentioned, it contains carbon less than 0.25. So, it will resemble more of characteristics like the wrought iron, and it is called mild steel. So, you can understand the tensile strength will be less of mild steel, that of high carbon steel, which is resembling more of cast iron, will have higher tensile strength. But you see here the carbon in case of high carbon steel is restricted up to 1.5%. If you look into the metallurgy, as I tell you, I am not extensively telling you on that, carbon at 1% gives the best kind of steel. So, you see something high carbon steel, and that too up to 1% carbon, and once it goes beyond 1%, again the qualities go down. The best is getting steel at 1% carbon. So, we see the different grades of steel are available. So, low carbon, medium carbon and high carbon, and we see that the properties is it can achieve higher tensile strength, compressive strength, it can withstand wear and tear better than wrought iron, better than cast iron. It is soft and malleable, can be rolled into thin sheets, and hard steel can be used for making tools. If you remember, in the previous lecture we had given a diagram where various types of steel were in between, cast iron and wrought iron. So, more carbon content steel will resemble cast iron, which will be useful for making tools. Steel containing carbon of 0.3 is required for high strength structural purposes. And you see the two values are given. The mild steel is having a compressive strength of 10,000 Newton per kg per centimeter square. Tensile strength of mild steel is 7,000 kg per centimeter square, and the same is given for high carbon steel. So, high carbon steel will have higher strength, 180 Newton per millimeter square and 100 Newton per millimeter square, rather 18,000 kg per centimeter square or 10,000 kg per centimeter square. Now, coming to the process of rolling of steel. Why we are coming to this? Because we as architects, or we need to know how to use steel into the building industry. After knowing the basic properties, as we all know steel is good in tension, we will have to make use of it into our buildings. We also know it is very heavy, so we have to think of lighter weight, proper sections to be used, which will be more effective. So, just not taking a big rod of iron or a piece of a large bar of steel, but we need to know how best we can use it, and that is why we need to know rolling of steel. It is a metal forming process in which metal stock, that means instead of taking the entire wood log, instead of taking the entire steel piece, we will roll it into our desired shape, desired thickness, uniform cross section by pressing it. So, if it is in its molten form, it will be easier, not 100% molten, but at a temperature where it can be easily passed through rollers without any deformity. So, one type is hot rolling, other type is cold rolling. So, the metal is, when it is passed through the rollers under pressure, it is at a higher temperature, but the temperature, if it is below the recrystallization temperature, it is called cold rolling. So, if we are doing cold rolling, we are not changing the crystallization structure inside the steel. If we are going for hot rolling, we are changing the crystallization pattern inside the steel. I am not elaborating much, but we will see in one case where how this thing changes. So, the TTT diagram is there, which I have not covered in the lecture, in any of these lecture on this module. the time temperature transformation diagram of steel that gives a vivid explanation, though we need not know so much of details. So, just by putting the stock under pressure of rolls, we get different cross sections which can be used for our purpose. We will go into that little later. So, what we see, these rolled steel sections can be directly used for structural purposes. And I have told you we can get different shapes of it. The IS code is there which gives the details of such shapes. Usually there is a thin member web and a projected member that is called the flange for every member. Say if it is an I section, now you can, I think, understand what I mean of this rolled section. It can be a channel section, it can be an angle section, it can be a circular section, hollow, it can be a square section, hollow. So, this is called an I section, this is a T section, this is an angle section, this is a channel section, etc. So, you see here it is written as ISLB, which is I section. As per code it is written 500 at the rate of 735.7 Newton per meter. That means 500 is the depth of the I section and 735.7 Newton per meter is 1 meter length weight. Same for T, it is ISNT 125, that means the depth of the T section is 125 millimeter, this is also 500 millimeter and the rest is the weight. Same with the channel section, you see ISLC 350 at the rate 380.6 Newton per meter. So, this is actually 380. Now, these are all 350 millimeter. So, these are all code specified. So, you just cannot order any number which you desire. So, there are lists in the code and you have to order based on it. The weights are also given and you will see all these items have an inner slope. It will have an inner slope. You see this is an angle section. This will also have an inner, it will slope outside, means it will be tapering at the outer end. That is the angle section ISA 40 into 25 into 6 millimeter. Here the weight is not written, not given. It is written as one is 40, one of the arms is 40, other arm is 25 and the thickness is 6 millimeter. Coming to MS flats, that is, you can see on top of railings you can see a flat bar like this. This is 30 wide and 10 millimeter thick, 30 millimeter wide and 10 millimeter thick, and having a length whatever you desire. You may have plates and sheets ISPL, ISSH, that gives the dimension of the sheet. See, 2000 into 600 into 4 millimeter or 2000 into 600 into 4 millimeter. So, these are the various types of rolled section available, and these can be directly used for construction purposes. Why I mention this? Because other than these, we have reinforcement bars. Reinforcement bars, or precisely called, abbreviated called rebars, they are actually embedded in concrete. When we had covered concrete, we had understood reinforced concrete, where reinforcement was embedded inside concrete to take care of the tensile forces which a structure would experience, because concrete was good in compression and not good in tension. We will cover reinforcement bars in the later lecture, but now we will carry on further with the rolled steel. Here you see a number of pictures which I could collect. Sources mentioned. These are angle section, box section or rectangular section. You can see channel section, circular hollow bars, steel plates, and or even the rebars or the steel bars. You can see these in your daily life, daily places where you visit, a cycle stand, a shop in a temporary kind of shop where you will see circular hollow bars, steel angles being used for putting up the roofing or temporary roofing or lightweight roofing on top of a structure. A garage, temporary structure. Try to look around, you will find all these kind of sections. Even the railway tracks, those are kind of T section. Those are also rolled out. So, rolled sections are directly used in structure, they need not be embedded inside concrete. So, rolled steel is used directly for steel structures, even steel structures for building industry. We can see steel structures completely where reinforced columns and beams are replaced by steel members. Sometimes an intermediate support is required. There you can actually put a steel member. Steel being both good in compression and tension, it does not need concrete along with it, but concrete requires steel along with it. These steel structures, wherever used, they are very stable and they can take load. They can take both tensile as well as compressive load, and hence I sections T sections can be seen used for steel structures. We now come to the most interesting part of joining metals. Once we get these rolled items, how to join them together. In case of bricks, we had seen mortar was joining the two. In case of engineered wood, we found adhesives joining the two. In case of metals, how do we join them? If you want to directly join two pieces, we have three processes: soldering, brazing and welding. Both soldering and brazing requires a second metal or a metal alloy, which is a kind of adhesive between the two mother metals or the metals to be joined. So, if you have two metals to be joined, you are putting a third metal liquid in between and joining it, allowing it to join, and that is a third metal should have a lower melting point. Soldering is usually with tin and lead alloy or lead and silver alloy, and which this alloy melts at 300 degrees centigrade. So, what is happening that at 300 degrees centigrade, when the mother metal is not at all melting, it is just getting heated, this third metal comes in between, the second metal alloy comes in between in its liquid form, and it holds the two metals together once it is solidified. But this is a weak joint. Brazing also has the same type of joinery. Here the temperature is little higher, that is 600 degrees centigrade, and the filler metal passes in between the two metals. The gap is very small, but even then these are the two work pieces to be joined, and the third metal or the metal alloy percolates in between the two. But welding is little different. What is happening in welding? Here actually the metals to be joined are heated to almost its melting point, and then when it becomes soft, the two pieces are hammered together. That is a traditional way of doing. Now different easier methods have been found out, but it is the same two metals being joined. There is no third metal coming, there is no other metal coming in between. But even then these points are weaker than the main material, but this is the strongest amongst the joints. So, let me summarize: soldering, brazing, welding. In all these three cases, you are using heat, another metal into the application. When you are using heat, it is the third material in its molten form is getting in between the two metals to be joined, and this is happening at a lower temperature, which is called soldering. The other is called brazing. Welding gives a better joint, stronger joint, and no third metal inside the process. There are modified or more easier methods of welding, gas welding, arc welding, etc. Here you see the person wearing a mask and doing the welding. There are different types of welding. See the butt joint, T joint, butt joint is placing one beside the other. So, one beside the other, as we had the joinery in case of wood, if you can remember, the lengthening joints. Here you see you want to make a different complex picture, complex structure. Here you see it is a corner joint. So, this joint is very important here. This is a lap joint that is overlapping with the other member, and this is an edge joint. So, these two items are joined together to even increase the thickness. So, all these are possible with soldering, brazing as well as welding, and you can see these are quite similar to that of your wood joinery. Now, coming to the other kind of joint, that is the mechanical joints, which can be done to join two items, allowing some movement, allowing some possibilities. We see rivets, we see bolts, we see screws. This picture is rivet, which is a permanent joint. See the cross section here, where you see the pin is the shank of this is passing through the two metals, and on the other side it is hammered and it becomes a flat. It is completely sealed, you cannot open it. Unlike this nuts and bolts, you can screw, you can open it through the thread, it is being fixed together. This allows movement. Say you want to have a hinge kind of thing, it will move. So, nuts and bolts, it is temporary kind of joint, you can open it. Screw is also the same, you can unscrew an item. So, rivets are permanent kind, you will see riveting done for steel structures where it becomes a rigid body. You can see screwing of structures, steel members, where you can unscrew it. You can see use of nuts and bolts, where again you can take out the nut, you can take out the bolt and again use it for some other purpose. So, with this we end this lecture, that is lecture 3, and we will move to lecture 4 in our and we will discuss more on the rebars or the reinforcement bars part. Thank you.